Good afternoon. Welcome back. Josh, and I'm here at Arizona Science Center, and we are so glad to have you continue our this morning at 9:30 with our early learners live, as we had a bunch of astronauts in training practice and develop their own astronaut skills that you can continue at home. But for today's 1 p.m., I'm talking a little bit to let a few. So as we continue our space journey, I want to ablative. Raise your hand virtually. Give us if you have ever heard the phrase ablative shielding, or if you even know what ablative means. No, that's okay. I didn't either, but that's demonstration. Ablative essentially is just a word that means when things separate, and there's a force that when things separate. So if we are talking about today's space journey, right, we had our wonderful astronauts in training this morning that learned how to take their rocket ship and fly up into outer space, and once they've safely explored the moon, we have to make sure that they safely get back home. However, when a rocket is re-enters the atmosphere, they're going really, really fast. Comment below if you have any idea how fast a rocket is going when it re-enters the atmosphere. I'll take a few guesses. Cool. If you said 80 miles an hour, that'd be pretty fast if you're going on the freeway, but it is much, much faster than that. If you said 8,000 miles per hour, you would be a lot closer, but a rocket goes much faster than 8,000 miles per hour as it re-enters the atmosphere. A rocket ship can actually be going about 17,500 miles per hour as it re-enters the atmosphere. So when I'm talking about the atmosphere, I'm talking about here's the Earth, and the atmosphere is all of the ball of trapped gases that keep heat and keep warmth, and all of the air and all of the things that we need to survive on the planet outside. So the atmosphere is all of the trapped gas around Earth, and as the rocket is flying through space and it's going super, super fast, and it goes and it hits the atmosphere, all of that trapped gas, it's just like if you've ever belly flopped into a pool, right? If you're falling through the air, it doesn't really hurt, and then you hit a much denser medium. That's really what happens to a rocket ship when it hits the dense atmosphere. So all of that friction from hitting a dense thing like the atmosphere causes a lot of heat. Another way to think about it is if I go down, there was not super fast, there was no friction on my knees maybe a little dusty, but they are just fine, and there's no burn. However, I'm running super, 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 super fast, and I go and I skid. What's going to happen to my knees? Right? It's going to be burned. It's going to hurt from all of the friction. So if I'm running super, super fast, and I burn my knees because of the friction, rocket ships, which again can be going over 17,000 miles per hour when it hits the atmosphere, experience a lot of friction. So we need shields, aka ablative shielding, with today's 1 p.m. live science demo, to keep our astronauts safe and protected. To simulate this, I've got a bunch of stuff that we get to set on fire. Come with me. Cool. So for today's activity, we are going to be creating different shields out of household materials to simulate how we keep our rocket ships and our astronauts safe as they re-enter the atmosphere. So if you want to look, I will continue to let our video camera. We have some steel plates. These are some wire brush sponges that you might use to really scrub some heavy duty pots and pans. Here are pieces of cut cork board. Here are small squares of mirrors. Here are uncooked lasagna noodles, delicious when cooked, but we're not going to eat these ones. This is just regular paper. And these are chunks of solid copper. We have paper plates. We have some felt, just like you might use in some of your arts and crafts projects. And we have some copper mesh because I thought it might be fun. So for today's shield, we are going to use 3 materials. Safety gloves are thick. We're going to use 3 materials. If you would like to make sure that your favorite material gets picked for today's shield, go ahead and comment below, and anyone who comments the first 3 comments, I will use those first 3 materials. Nothing, which means I get to pick my favorite. Keep in mind, the first 3 comments, we will use your materials. However, for today's shielding activity, I think pasta is delicious, so I am definitely going to be making a shield with our uncooked pasta. I think that cork boards are pretty nifty, and this is wood, and I'm used to wood burning, but it also is kind of squishy, and I wonder if that's going to do anything different. And I want to set a piece of paper on fire because I get to set things on fire. Oh, the carpet.
Copper.
Copper. Oh, all right. So somebody beat me to it. We will get rid of the paper, and we're going to use one of these chunks of square copper. So
we actually have 3. So we have copper, lasagna noodles, and paper.
okay, I get to keep my lasagna noodles, so I'm pretty content. All right, so first 3 have it. If you're really enjoying today's demonstration, and I hurry up, we may be able to get through 2 shields. But for the first one, we have lasagna noodle, we have copper, and we have a piece of paper. I'm going to put this piece of paper on the outside. And if you would like to step back down, and we can now get a full view of our ablative shielding stand. For today's shield, right, the 3 materials that you all picked, thank you so much again for joining us. We have paper. I'm going to break off a chunk of our lasagna noodle, and we have a solid chunk of copper in the back. This is one of our specially made ablative shielding stands that is going to allow us to use large binder clips to clip our materials in place with a little bit of finagling, I think that's the word. If you know a better word than that, let us know in the comments below. Cool. And the way this is going to work, this propane torch is still locked, so I'm not wearing my safety gear just yet. I am going to rest it here, and if you look, I'm doing that to test. We need to move our shield down, and the way this is going to work is simulate, right, this is our ablative shielding demo, so we are simulating how rocket ships are protected to keep astronauts safe. And to keep our astronauts safe, we are going to use an egg, which is going to stand up right here. So, because I'm now going to start setting things on fire, my favorite part of my job, I'm going to introduce my lovely assistant,
Valerie.
Cool. And Ms. Valerie has 3 very important jobs. So Ms. Valerie is going to be, 1, physically putting the eggs on to keep it safe. She also has a thermometer. And Ms. Valerie, what are you going to be using the thermometer for?
We're going to see how hot this egg gets. Our eggstronaut.
Our eggstronaut. Oh, I see what you did there. Very nice. So she is going to be checking the temperature because we may see some physical changes. You all, I think, crafted a lovely shield, but we also need to be checking the temperature of the egg. So, and then the third thing Miss Valerie is going to do is she is going to have a 2-minute timer up on her phone, and we are to the eggstronaut, for 2 minutes at a time, and we're going to see how effective the shield that we all made together. Are you all ready? Perfect. Miss Valerie, if you would like to do the egg, I'm going to make sure that all of my PPE, my personal protective equipment, is on. These are very high heat resistant gloves. Put that on over my lab coat. I'm going to unhook this. And because Miss Valerie's in control of the time, every good blast off, or in this case, re-entry, needs a good countdown. Miss Valerie, you give us a countdown?
Here we go. 3, 2, 1.
Oh, there we go. So as you can see, the paper immediately cut through, but if you can see at home, underneath the blue flames from the propane torch, the lasagna noodle turned black, but is still hanging tight. So, we currently have 1 layer of protection gone almost immediately. We can see that the pasta noodle is continuing to fry and turn black and char, but it's still hanging in place. So we haven't even gotten through our 2nd layer of protection. Let us know in the comments what you're noticing and what are your observations. So far we have done a fantastic job of protecting our eggstronaut, and we're just going to keep listening and see what changes. And so in comparison, if we're at 60 degrees on the eggstronaut, if Miss Val can safely come around and take the temperature of the back of the shield, we can start giving out lots of temperatures for comparison.
All right, the back of our shield is at 170 degrees Fahrenheit.
So the front of our shield, whoever chose the lasagna noodle, well done and thank you, because this is an excellent material. Good.
Oh, that's 2 minutes.
And that is our 2-minute timer. It smells like a birthday cake in here. So, and if we look, here is our eggstronaut. Right, so we're looking for any signs of discoloration. We're looking for, smoking and smoke detectors. But we're looking for any signs of discoloration. Do you all see any? No, we didn't even start to heat the outside of the shell. So that was our demonstration, but because somebody left me in charge of setting things on fire. If you all would like to see one more shield, let us know. If we can get 3 more materials by the time I finish explaining the science behind this, we can do one more demonstration. If not, thank you all so much. And thank you again for continuing to practice physical and social distancing to help us flatten the curve and help us all remain as safe and healthy as possible. We really appreciate that. Again, my name is Josh here at Arizona Science Center. If you enjoyed today's demonstration on Facebook Live, don't forget to check us out on Instagram. All of our Facebook Live videos and many other supplemental videos are being uploaded to our awesome YouTube channel, or you can find lots of do-it-yourself resources for science activities for you and any other young scientists in your neighborhood or in your area at azscience.org. So, have we gotten any more requests for materials?
We have cardboard and copper so far. We don't have a third.
So I do not have copper, but I have copper, I have corkboard, if we would like to try that. Unfortunately, I don't have cardboard with me. But the way it works, as you can tell, is when the rocket re-enters, and quickly, in the comments below, how fast is the rocket ship going when it re-enters the atmosphere? Ms. Val, do you mind putting that back before I drop it? And once. The rocket ship re-enters the atmosphere, for those of you who are just joining us, at speeds of sometimes upwards of 17,500 miles per hour. So all of that causes a lot of friction, causes a lot of heat, which we're simulating today. In case you are curious, this is the front side of our lasagna. This is the back side, so you can see that even with the intense heat that was directly on the lasagna noodle almost the entire 2 minutes, right, the paper flared up immediately, it didn't even get all the way through the lasagna noodle. And if you look, this is the front side of our copper square, which I am perfectly happy to use again because it was still completely protected on the back side. So excellent job with your shield. We can do one more shield. I heard corkboard, I heard copper, and did we have anything else? Going once, going twice, perfect. I want to do a sponge because I want to. Cool. So, once again, I'm going to clip our materials onto our stand. Thank you, binder clips. You are wonderful, and I appreciate you. No. Sorry. I forget how much I talk to myself until I'm doing it on camera. But we have our shield nice and secure in place. So, Ms. Valerie, whenever you are ready, if you would like to put our Astronaut back on. And we are going to do our comparison one more time, and we're going to be tracking the heat for the egg. We're going to be tracking the heat from the back of the shield, and if possible, if we can safely, we will get the heat from the front of the shield because you can actually stand all the way behind your thermometer. Awesome. Are you all ready for round 2? Perfect. All right, I'm getting some nods. Perfect. We hope you all are enjoying today's live science demo, and we need a countdown. Ms. Val, whenever you're ready.
All right, here we go. 3, 2, 1.
Whoa! So the sponge makes a lot of smoke. If we set off the smoke detectors, you all know why. And this is fire. So that's cool. We are definitely through. Oh. Anyways, if the alarm goes off, we will evacuate properly. And we thank you all for joining. We are all the way through the sponge. We are now in layer 2, which is the cork, which you probably can't see. But because cork is wood and also has the air in it, it is starting to bubble up, and it looks like pockets of the corkboard are still going through, but we are mostly onto just the copper. Let us know. We have about 1.5 minutes left. Do you all think that the copper plate, which has already been torched for 2 minutes, do you think that is going to be enough to keep our Astronaut safe for the remainder of the second trial?
Right now our egg is at about 80 degrees Fahrenheit. Oh, there's flame coming through the other side.
So the Astronaut is about 80 degrees. It didn't get higher than about 60 degrees Fahrenheit. So our poor Astronaut may be feeling a little bit warm.
It's like 265.
But the back of the shield is 265 degrees. Part of, if you watch Sari on Science's combustion demo, we know that oxygen is one of the key elements of the heat triangle. So we had 265 degrees on the back of the shield. What's the front?
It's 800 degrees Fahrenheit.
So we have over 800 degrees of heat coming from the front part of the shield. Obviously leave this to the professionals. Please do not try anything like this at home. But we are going, and we've got probably 40 seconds left. And what's interesting, if you notice, in the first experiment, we also had a material that flared up right away. That was the paper. However, the paper dissipated really quickly, right? All of the heat burned it to a crisp, whereas the sponge and the corkboard are both continuing to serve as fuel, which is making the heat stronger and more intense for a much longer period of time. And that was our second shield. So we're going to safely remove the egg. Miss Val, here's your egg shell.
I'm trying to turn off the
As we're getting rid of the timer. There we go. Oh, you got it?
Yep.
Perfect. And because of very heat-resistant gloves, we're able to safely extinguish the fire and remove this. We also have a sink right behind us. And that really is to just, right, you can see the steam and hear the steam. That's just to help us dissipate some of the fuel that was remaining, right, especially with the corkboard trapping the air. Anyways, that was today's demonstration. I've already taken a lot of your time, but if you are interested, this is our ablative shielding demo. Again, my name is Josh here at the Arizona Science Center. This was our amazing assistant, Valerie, and Cole is behind the camera. Thank you so much. If you enjoyed today's video, check us out on Instagram. Check us out with our online learning resources, or you can always find all of our information at azscience.org. Thank you all so much, and we look forward to seeing you tomorrow. Bye, everybody.